All right, let's continue on doing some differential equations. I'm very excited. I don't know about you guys, but after a long, hard week of work on a Friday night, I like to unwind by doing differential equations. So join me and let's have some fun. Today we're going to do some exact differential equations. If you recall, an exact differential equation is of the form m of xy plus n of xy dy dx is equal to 0, where m of xy is a function of x and y, and n of xy is a function of, wait for it, x and y. So in order for this equation to be exact, the partial derivative of m with respect to y must equal to the partial derivative of n with respect to x. And it can get a little confusing, so we took a very simple example. There's a lot of differentiating, integrating, blah, blah, blah going on. So let's look at this equation. Is it exact? That's the question. It looks like it's in a pretty good form. It's in the form m plus n dy dx is equal to 0. So we have our n. So we're going to take the partial derivative of m with respect to y. What is that going to be equal to? d dy of 2, not y, getting my x's and y's mixed up here. 2x plus 3. So what is d dy of 2x plus 3? Well, there's no y term in this, so everything is treated as a constant, so it's just going to be 0. All right, now let's take the partial derivative of n with respect to x. What is that going to be? It's going to be d dx of 2y minus 2. Well, again, in this case, there's no x's in here, so it's just going to be, everything is going to be treated as a constant, so we're going to get 0. Okay, now the question is my equal to nx? Is 0 equal to 0? Loaded question, I know. Go to ChatGPT, go to Google, go find out. Tell me, is 0 equal to 0? Well, I'll give you a little hint. Yes, 0 equals 0. So this is an exact equation. We can solve it by using this exact equation solution method here we got. So remember the theory behind all these exact equations is to find a potential function. Sorry about that. My Apple Pencil died, so I had to go give it the proper burial, proper funeral. Now I got myself a new and improved good old Apple Pencil, so let's keep on chugging along. All right, Mr. Apple Pencil, help me chug along here. Where were we? Okay, we've found out that this equation is exact, so the next step is to find a potential function. We want this potential function f of xy that's going to be a solution to this differential equation. And the theory of this says that f of x, derivative of f with respect to x, is equal to m, and fy is equal to n up here. So we're going to use this knowledge to do some differentiating and integrating to find the solution. So the next step, we can either integrate f with respect to x, or we can either integrate m with respect to x, or we can integrate n with respect to y. Usually you want to do whatever is easier. In this case, I think they're about the same difficulties, so we'll just go with integrating m with respect to x. Let's be wild and just take a gander, take a guess. Okay, so if we integrate this, we're going to get, f of xy over here equal to the integral of m, which is just going to be 2x plus 3 dx. What is this going to equal to? Well, if you remember from your calculus classes, basic integration, 2 of x is going to integrate and become x squared. 3 is going to be 3x. We also want a constant. But since we're integrating with respect to x, this constant could be either just a regular old constant, like a number, like 3, 5, 10, blah, 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 or it could be a function of y. So we're going to go ahead and put g of y here. This is key. So now basically we have this potential function f of x, y is equal to x squared plus 3x plus g of y. But really we still need to solve for g of y to get the full solution. So how do we do that? Well, and like I said, this gets a little complicated. First we had to integrate with respect to x. Now we're going to differentiate with respect to y. So what are we going to get from that? We're going to get f of y is equal to, and what's the derivative of this with respect to y? Well, all the x's are going to be treated as constants. So it's really just going to be, we're just going to differentiate the g of y term, and we're just going to leave that as g prime of y, because that's what it is. We don't know the function yet, but that's what we're going to find out. If you remember what I said earlier, f of y is equal to n. So n, if you recall, is 2y minus 2. Just getting that from the equation up here. Just simply getting that here. Oh, sorry. I think I messed this up earlier. This should have been 2. 2, blah, blah, blah. This is 2. So, yeah, this is 2. No magic happened. I just had a little typo, whatever you want to call it there. Okay, so now we have 2y minus 2. That's f of y. That's equal to, that's n. So that's equal to g prime of y. So now we can solve for g of y. This is our last step, and we have the answer here. We can solve for g of y by integrating 2y minus 2. Once again, pretty simple integration. It's just going to be y squared is equal to, y squared minus 2y. Not actually, this is not f of y. Sorry, this is, so y squared, sorry for all the confusion here. Y squared minus 2y is equal to g of y. So that's it. We have our full answer now. Let's just combine all the terms. Let's just write it all out. So f of xy is the solution to this differential equation is equal to x squared plus 3x. I'm just getting that from up here. Plus g of y. But remember, now we have g of y. That was the point of doing the differentiation. So now we have y squared minus 2y. So now we have everything. All right, the party is done. We can also, usually the convention is to write this as, so we're going to have a constant term. So the convention is to write this as x squared plus 3x plus y squared minus 2y, it's just the equation I have up here, equal to some constant. That's going to, because that's just the way most differential equation professors prefer you to write it, and it's related to how curves are and all that. And we'll actually get into that in a few more videos. I'll do a couple videos to go over why we do that, but that's just more of a convention. Basically, these are the answers right here. So, all right. Hope you had fun doing a good old differential equation in exact form.